My name is Sarah Ward. I'm a master's student here at the Andrews. I look at spring phenology in different microclimates around the Andrews at a different elevation gradient and topographies, and we're sort of looking at how regional climate patterns are going to affect those localized smaller climates and how that's going to in turn affect spring phenology at the Andrews. The beauty of the Andrews is that it's a long established research forest, so we have data going back as early as the 40s for some places, so we can see an overall warming trend at the Andrews just in mean annual temperature, and as a result, what I look at specifically, we've got data from 2009 until this year, and we're seeing spring plant phenology, so what time bud break happens and what time different leaf out events is advancing, so it's happening earlier in the year, especially when we have years where there's low snowpack. We had a year like that 2 years ago, and we had as much as 43 days advancement in bud break for some species. One plant advanced 85 days early, so that's a 3-month difference. So that's basically greening up in January versus April. So one of the effects of differences in the timing of phenology, so advancement of spring bud break, can be negative effects on migrant birds that are arriving. So we call this atrophic asynchrony. It's if the migrant birds are often responding to the climate where they winter, which might be South America, and so they're showing up here when they normally would. And if it was a year like 2 years ago and the snowpack didn't happen and the bud break advanced a month early, the birds are showing up 30 days after the peak spring green up, which is also when the bugs tend to emerge, so they're losing food source for their babies, and they're existing in a less ideal habitat than they may have if they had arrived when the spring green up was happening. It's definitely hard to eke out the exact response we're seeing to overall climate change and warming patterns, but we are seeing an effect, and in terms of adapting to it, it's going to take more research and more data collection to really see the actual effects outside of just interannual variability. So citizen science can be really helpful for us to get a greater picture of the overall Oregon area rather than just this single point in the Oregon Cascades. So it can be really helpful to have citizen scientists going out and collecting data that's similar to the data I'm collecting, and then I can look at the entire state of Oregon or the region of the Northwest depending on who's out there and what they're collecting. So it can be really beneficial to have this greater data set collected by the public.